weight and balance equipment. What equipment are we going to need to balance our aircraft? Okay, in this module, you're going to learn the difference between scales, whether we're using a mechanical scale or an electronic scale. Different scales will be used to actually weigh the aircraft. We're going to illustrate the purpose of a spirit level. What is a spirit level? Where do we use a plumb bob? What's the purpose of a plumb bob? And a hydrometer. Why would we want to use a hydrometer to perform a weight and balance on an aircraft? We'll explain the effects of temperature on the fuel, specific gravity, which is going to overall impact the weight of the fuel, which could impact how our aircraft actually weighs out and where the center of gravity is actually going to fall. So, types of electronic scales. We're going to deal with two types of electronic scales. First, we're going to look at the platform scale, and we talked about these a few minutes ago. These scales here, they can come in two different modes. The kind that we have here is actually an electronic scale, or a platform with a load cell in it. You could have a scale that looks identical to this, but it would be a spring scale. Notice here on that back scale, we have a chock that's sitting up there. We have a special name for that chock when it's sitting on the scale, if you remember what that is. That's right, it's tare weight. And what do we do with the tare weight when we're doing a weight and balance? That's right, we subtract that from the total weight of that scale. So what we could do, actually, we could set the chocks up there and zeroize it with the chocks on it, or zeroize it with the tare weight on it. This particular scale system has that option, not all of them do. But we'll have it set up, and we want to leave that chock there when we roll the aircraft up on, because we don't want to roll too far and have it come across the front and have an airplane get away from us. That probably would be a bad thing. I'm not sure we'd last real long in the shop if the boss came out and saw the airplane rolling across the hangar floor. So we'll leave the chock there. We'll roll that aircraft up onto the scale, and then we'll put a chock behind it. Whoops, let's back up here. We'll put a chock behind it so it doesn't roll anywhere. And then the other type of scale that we're going to look at is going to be the electronic load cell that actually goes between the jack and the jack point on the aircraft. Here what we've got in front of us, now we've got the computer. This little computer is what actually reads the calculations that each one of these load cells has. It's a digital display. We can use this to show the total weight of the aircraft, or across the bottom there's a series of buttons, and we can select either the left jacking point, or the right jacking point, or the nose jacking point, so we can determine what each scale actually weighs. And remember, we're going to need to know that when we calculate the center of gravity, because we're going to have to know the arm from the datum to that nose jack point, and we need to know the weight of that jack, don't we? Same thing with the two mains. Here we've got our Cessna 150 sitting up on the platform scales. We've got our chocks on there. We need to calculate the tare and subtract that from the main weight. And then we've also got, sitting on that rack right there, we've got a computerized system that is actually telling us what the weight of each wheel is. Here's a close-up picture of that. And if you look really close across the top, it's got a 1 and a 2 and a 3. And if you look on top of the 1, there's a red. And if you look on top of the 2, there's a blue. And if you look on top of the 3, there's a yellow. Also got a power on-off button on the bottom right-hand corner. I can convert it from kilograms to pounds. But the color coding, why do I even care about the color coding? If I follow that color code all the way out to the scale, I'm going to see that red color code actually goes to the left main. And the yellow one goes out to the right main, and the blue one is the nose tire. And again, I need to know what the left main weighs, and what the right main weighs, and what the nose weighs. It's possible the nose is going to weigh 1, the left main is typically going to weigh 1 weight, the right main is going to weigh something completely different. They're going to be within reason, but they're not going to be identical. They shouldn't be identical. If they are, I would be a little bit suspect. Okay? Before I get started, before I roll my airplane up on the scales, remember, I need to zeroize the scales. I zeroize each scale so they're all reading 0, and then I pull my aircraft up on the scales, and then I can go ahead and I can select each individual button to determine what the left main weighs, what the right main weighs, and what the nose weighs, okay, or the total weight of the aircraft. If I add the left and the nose and the main up, That ought to be the same as the total weight of the aircraft. Whoop. And here we have a close-up of the load cell. Okay, we just looked back here, we had platform scales. Our other electronic scale is a load cell, works on the same principle as those platforms. And what that load cell does is that measures the weight between the jacking pad and the jack. And then all that information is fed back to our electronic box, which you can see I'm hooking the wires up to here. Again, if I look at each one of these, you notice they're going to be color-coded just like the platform scales were color-coded. I want to make sure that when I'm paying attention hooking up here that I get the red one hooked up to the red, the blue one hooked up to the blue, and the yellow one hooked up to the yellow. And then I need to know which one is on which position. Is the yellow still going to be on the right main? Is the blue still going to be on a nose? Is the red still on the right main? I need to know all that information, because not only do I need to know the weight of each jack, but I need to know the location so I can measure the arm from the datum. Here we're setting that, we're getting everything in position. We've got the load cell on top of the jack, and then we've got the jack pad there. We're starting to bring that jack up, and we're starting to seat the jack so that all four legs are on the ground. I've already zeroized those load cells. I have to do that before I get to this step. If I don't do that, I'm not going to get an accurate weight. If I put any pressure on that load cell and then zeroize that jack, I'm not going to get an accurate weight. It's not going to work. So my Beechcraft now, we're getting ready to go ahead and jack it up. In the process of jacking it up, on the Beechcraft, if you look back behind the window, you've got your door. The door actually kind of rounded corners, comes like this, okay? And then just forward of the door, we're going to find two Phillips head screws here and here, okay? And what the tech manual, the service manual is going to do is going to tell you to hang a string around the top here on a plumb bob and bring it on down. When I get that aircraft jacked, okay, that string should go from the top screw right straight through the center of the screw. That tells me the aircraft is level, the same level attitude it would have in flight, which is what I want for when I do my weight and balance. If the nose was a little down, that string might be hanging here, okay, and then my plumb bob would be hanging down here, which would tell me I need to bring the nose up a little bit. Or if the string was hanging back here, that would tell me that maybe the nose is too high or the back is too low, and I would have to adjust the nose or the tail to get that string so that it comes right straight down through the bottom screw. If I don't get it through the bottom screw, I don't have a level aircraft, and I can't get an accurate weight and balance on what I'm doing. Okay. Hopefully the door on your airplane is a little squarer than the door on my airplane. I failed Art 101 a couple years ago when I tried to take it. Okay, so let's move and let's see here. Aircraft, again, must be in the flight level position. On our airplane here, on the 150, when we were working on it, we read the type certificate data sheet, and they wanted us to measure the level of the aircraft at the top of the door sill. So we've got a prop protractor, a propeller protractor that we're using. It was actually small enough to get in there and get it actually level. In order to get that aircraft level, we would either have to take and let some air out of the nose tire or possibly inflate the nose strut, but we want to get that aircraft in a level attitude. As soon as that spirit level gets in the center, we're good to go. Other 150s actually put a spirit level between the back window and the vertical tail, and we can actually put a spirit level on here. But for this particular aircraft, they wanted us to go ahead and measure it right here. And here's another picture of the spirit level. Okay. Although it's not required, for our purposes here, I also wanted to do a left and right. I wanted to get it, not only did I want it leveled from nose to tail, but I wanted to do a left and right. For helicopters, that's critical, but for small aircraft like this, it's not really critical. But I wanted to go ahead and get it level all directions. I just for the purpose of this video shoot, I wanted to make sure that we had it level all directions. And I had to let a little air out of one of the tires just to get it perfectly level. But But the goal here again was to get it good and level. Now, the plumb bob. Pretty inexpensive. You don't have to go out and buy the top of the line plumb bob. In fact, if you come to the school, you're going to find that we actually even manufactured our own plumb bobs. Nothing more than just a piece of metal hanging off a rope, and you can see it there. And what we're doing is we're going to measure on this particular, what we're doing here is we're measuring where is the leading edge of the wing. If I go to my service manual, I can measure from, it'll give me an actual measurement in inches from the datum to the leading edge of the wing. What I'm in the process of doing here is I'm trying to find out where is the center of that left wheel, or excuse me, that right wheel weight. What is the center of that? And I need to know that on this particular airplane in order to calculate the weight and balance. If I know that wheel weighs 650 pounds, I need to know what the arm is from the datum to that wheel, or I cannot calculate the moment. So the first thing I want to do is I'm going to use my datum. I want to get a perpendicular line on the aircraft. Okay, I picked the wing, and then I want to know the distance from the leading edge of that wing to the datum. And I want to make sure the aircraft is level. If the nose was up or the nose was down, I could be off an inch or two one direction or the other. Once I know, again, let's back up here one. Once I know what the measurement of each wheel is, okay, and I can mark it on the ground, then I can get my ruler out and I can double check all my measurements. I can check the measurement of both main gears, and again, their distance from the datum had better be identical. And then from the nose, you may have to measure from the main gear back up to the nose, or you may measure from the datum back to the nose gear. There's different ways to do it. The service manual is going to give you some ideas, but we have to have accurate measurements. If we were going to weigh an aircraft, a large aircraft, not a Cessna 150, but if we were going to get into weighing some large aircraft that had several thousand pounds of fuel on it, and you were going to weigh it with a full load of fuel, the temperature outside, ambient temperature, is going to change the weight of the fuel enough that you need to know what the actual weight per gallon of the fuel is, and then you need to know if the tank is full, how many gallons are going to be in that tank. And a hydrometer is a device that we would use to measure the specific gravity of the fuel, and then we can calculate the weight. When we get into aviation sciences, we'll actually get a chance to practice using the hydrometer and actually measure some specific gravity and calculate the specific gravity and weights. But just know that if you have a large aircraft and you have it full of fuel, you need to know what the weight of each gallon of gas is, and the only accurate way to do that is with a hydrometer. If you're supposed to be weighing the aircraft empty weight with no fuel, you're going to have to subtract whatever that fuel weight is from the total weight of the aircraft. You're going to need to know where the fuel tanks are. You're going to need to know the moment of the fuel tank, the arm of the fuel tank, so that you can calculate the moment. I will tell you that this procedure is not done very often. If there's a reason why you cannot empty the fuel on the aircraft and you still have to do a weight and balance, maybe we should recheck our priorities a little bit. I would still recommend that you do a complete defuel with only usable fuel, and then you do the weight and balance. If for some reason we want to go ahead and do a weight and balance with the full load of fuel, again, a large aircraft, you're going to need to know what each gallon of fuel weighs. And when you're talking several thousand gallons of fuel, it's going to make a couple 100 pounds difference in the total weight in the moment. Okay, so in review of this past module, what we should remember is the fact that there are different types of scales. You have electronic scales, we have spring scales, you have platform scales that could be electronic or spring, and then we have the scales that actually go between the jack and the aircraft. Those would be an electronic type scale. So just realize that there's different scales out there. You'll be using different scales as you go out and you weigh your aircraft. But your other stuff that we covered, we talked about a spirit level, or sometimes you'll hear it referred to as a carpenter's level. Just something so that we can measure that airplane and make sure that we get the nose in the same and the tail in the same attitude that it would be for normal flight, because that's critical during the weight and balance process. The plumb bob could be used. Some helicopters use plumb bobs. They have the target that actually sits on the center of the aircraft floor, the helicopter floor, and that plumb bob comes down. Remember, it's going to sit right, it's going to come right down in the center. Remember, we did that. We talked about how that plumb bob is going to fit. The King Air 90s, when we did the weight and balance on that, the plumb bob actually had 2 screws, and as it went forward or back, remember we wanted that string to go right down through the 2 screws, and that told me that the nose and the tail were level like it would be in flight. And then the hydrometer. Remember, we talked about the hydrometer. It's not a real common tool, but it's something that you need to be aware of. If you have to calculate the fuel load of an aircraft, depending on the temperature, is going to impact the specific gravity of the fuel, which ultimately will impact the specific gravity, or ultimately impact the weight of the fuel, which is going to impact where that center of gravity is going to fall.